3.5 Derivatives of trig functions. I've listed the derivatives at the top of the page. You should know derivative of sine is cosine, derivative of cosine is the opposite of sine, derivative of tangent is secant squared. Those will appear a lot. We also have the derivatives of the reciprocal functions listed as well. So we begin with some practice. What we have in the first example is a product. We can use the product rule while we take the derivative. F prime of x will equal the first times the derivative of the second. So the first is 1 plus 2x. The derivative of the second is negative sine x plus the second times the derivative of the first. The derivative of the first is just 2. So that'll be 2 cosine x. These terms cannot be combined, so we are done with that answer. In the next example, we have a quotient. We could use quotient rule here, or you might notice this is the same as 1/3 cotangent x. So let's take the derivative of cotangent. The derivative of cotangent is negative cosecant squared. So we're going to get negative 1/3 cosecant squared. The next example, find the equation of the tangent line to the graph of f of x at x equals pi over 3. So we're going to need a point and we're going to need a slope in order to do this. The point that we'll use can be found by evaluating the function. Since we are at x equals pi over 3, I'm going to evaluate the function at pi over 3. So 4 times the sine of pi over 3. The sine of pi over 3 is root 3 over 2. Therefore, I get 2 root 3 as the y coordinate. So the ordered pair is pi over 3, comma, 2 root 3. Now I'll need a slope. In order to find the slope, I'll take the derivative of the function. So the derivative of 4 sine x is 4 cosine x. And I'm going to evaluate that for pi over 3. 4 times the cosine of pi over 3. Cosine of pi over 3 is 1/2, and 4 times 1/2 is 2. So I have a slope and I have a point, and I can write the equation of the line. Y minus 2 root 3 equals 2 times x minus pi over 3. So I use point slope form, and when you do, you can be done. You do not have to change that equation. You could leave it in that form. The next example, we have the limit as x approaches 0 of sine 3x over 7x. Now I want you to think back to our exploration of the limit as x approaches 0 of sine theta over theta. I'm choosing to use a different variable here than x. We looked at this on the calculator. If you recall, the graph of this has a hole in it at x equals 0. So the input 0 will not produce an answer. It's not in the domain. But the graph looks like this. And the height of that hole is 1. So the limit of sine theta over theta as x approaches 0 is 1. Knowing that, I'm going to manipulate the expression that we have. We have a limit, and I'm noticing that the angle we're working with sine is 3x. So I'm going to introduce a 1. I'm going to introduce 3 over 3, which is 1. I can multiply top and bottom by 3. I'm going to rewrite the denominator. So in the numerator, we have a 3 in the first fraction. We have a sine 3x in the second fraction. On the bottom, I'm going to switch the 3 and the 7. So I'm going to move the 7 into the first fraction, and I'm going to move the 3 into the second fraction. Now, in the second fraction, the angle 3x matches the denominator. So now this fraction, the second fraction, takes on the form of sine theta over theta. I can go ahead and find the limit here. So this limit equals 3/7 times 1, which is 3/7. Our last example, we have a limit as x goes to 0 of x cotangent x And here is another case where I can rewrite the math problem to be able to do the limit easily. First, let's remember that cotangent is the same as cosine divided by sine. Next, I want to change this expression from a product to a quotient. So I'm leaving cosine in the numerator. So here I have cosine in the numerator. And I'm going to rewrite x, multiplying by x, as dividing by 1 over x. So in the denominator, I'll have sine x over x. Your limit laws allow you to change the limit of a quotient into the quotient of the limits. So I'm going to look at this as quotient of the limits. And now in the numerator, I can take a limit. The limit as x approaches 0 of cosine is 1. And that's because you could just substitute 0 into cosine x and you would get 1. But in the denominator, we're dealing with that expression again, sine x over x. So we know now the limit as x approaches 0 of sine x over x is also 1. So this limit is 1.